is basically you need to find the majority element in a given array. And what's a majority element? Any element in the array which is occurring more than n by 2 times. These where is the size of the array qualifies as a majority element. So the first solution which you can give uh, in an interview would be basically you would be telling that you need to traverse through the array, and for the each element you need to check whether it is having that many count, and that would basically be like having a time complexity of big O of n square, right? Since you're like taking each element and then researching in the array whether that qualifies as a majority element, that would be like of big O of n square. Now there is another step which you can do. uh, it would be requiring you to have some extra space here. So the idea would be to maintain a hash map where you will save the number in the key, and the value would be basically the occurrence of that number in the array. So that again, in this case you will be having a time complexity of big O of n, but you are also taking some space, so you will have extra space over here, and that would be big O of n. Now uh, going further, you can further optimize it, where like you can have the type complexity as big O of n, right? But you can like have like big O of 1 as an extra space. So the idea is basically to keep on saving the number which is having more count, right? Than n by 2 element. So there are different versions of it, of this question also, but we'll discuss that sometime later. So let's now get into the solution. So let me first write the code, and then I will be explaining the same. So let me copy the values from here. So in this video we are going to basically discuss the Moore's voting algorithm, which is going to give you the most best optimal solution, right? So yeah, this would be a code. And so let me first explain what is the idea over here. So we are having an element in the array, and every time we are checking whether this is the first occurrence. So if it happens that the number which we have uh, is basically having, like, the very first element, the count would be 0, right? So we take the very first number to be the candidate, which could be the majority. So here it would be 1. So 1 would be taken as a candidate, and later on, then we would go for the next element, we get 2. So over here count is obviously not 0, so we're not changing a candidate. We just check whether the candidate is different from the number which we have right now. So if the number which we have right now is different from candidate, we basically just decrease the count of that element. So it comes to be 0. So next time we'll go to 2, right? And once we come to 2, this time what do we find? We find that this 2 is uh, is going to be the candidate because count is 0. So candidate is updated to 2, and then we go to the next element, we find like 3 there, right? So 3 is basically not the candidate, so we decrease the count to 0. Next time 3 comes, right? uh, it is going to be like used as a new candidate because this time count is 0, so candidate would be updated to 3. Next again, when once we reach the last element, so we have uh, num equal to candidate. In that case count would be increased, and so whatever is the count right now, it's not 0, and the size of the array is over, so we have a candidate with us which is 3. So the idea over here is basically any element which is going to be in majority would not be cancelled by any other element. So for example, if we have 1, if we take 1 as a majority, next time it is getting cancelled by 2. The reason being, whenever we are getting a number different than candidate, we are decreasing the count, and the next time we get 2, we are increasing the count of that candidate, and once we get 3, this 2 is getting cancelled by 3, so it comes to 0. The remaining 2 3 is basically increasing the count, as in the last two cases the num will be equal to candidate. So that is the idea over here.